Hi, welcome to Chemistry from the Beach. I think this will be the last installment in this series. Today what I'm going to help you do is figure out how to do electron dot diagrams, or sometimes these are called Lewis dot diagrams. There is a worksheet where you will practice. I'm showing you my periodic table because we are going to use that first, and then we will try something else. So there's rules. Electron dot diagrams show the element symbol, and the element symbol in the diagram represents the nucleus of that particular atom and the kernel, K-E-R-N-A-L, like popcorn, not like army. So the kernel are the innermost electrons, and then there's going to be a series of dots that will go around the element symbol that'll be the represent the valence electrons. So we need to know the valence electrons. We need to be able to identify the particular element. So let's just do magnesium. So first we want to use the trick way, if we can. So we're going to look at the periodic chart, and first of all, we have to know where magnesium is. There's magnesium. It's number 12, and its symbol is Mg. And it's one of the ones that we can use the trick of the periodic chart. Magnesium is in the S block of the periodic chart, and it's in group 2, which means all of those elements in group 2 have 2 valence electrons. So all I have to do is, this is the weird part, put down magnesium and then 2 dots. And you can put the 2 dots anywhere you want to. You can put them close together. You can put them far apart. I was taught a long time ago that you always put them on the same side together to start out with, but that's changing. That's changing now, and it will change when we start using these as little puzzle pieces. So that's all you got to do for magnesium. Remember, there will be anywhere between 1 and 8 valence electrons. Let's try another one that's easy from the periodic chart. Let's do phosphorus. So phosphorus, its symbol is P. Phosphorus is another one that's in a convenient area of the periodic chart that has a weird rule. So it's in the P block, and it's in group 15, and so that means it has 5 valence electrons. So back to doing this for phosphorus. You put phosphorus down, that represents the nucleus and all of the innermost electrons. Now I need to place 5. Once again, there are some rules about this, but I usually start out by putting 2 valence electrons, and then I spread them out, just like they would be spread out if they were in an orbital diagram. So there's phosphorus with its 5 valence electrons. If we do something like chromium, okay, chromium is in the D block. You can't use anything fancy. You actually have to do the electron configuration. So chromium has 24 valence electrons. I chose to write them out. If you look on here, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. So it follows the sequence, as hopefully we've been doing a lot of. And then the rule says that you go to the highest principal quantum number, not the last thing that you wrote. It's not over here in 3D world. It's actually the highest principal quantum number is that 4. So that means, and there are no other 4s, so that means that chromium has 2 valence electrons, because that's how many that are in that particular orbital or sublevel. So chromium, 2 dots. It looks just like the magnesium, but I had to determine that using the electron configuration. We can do them all that way. I mean, I could go back and do phosphorus. Phosphorus has 15 valence electrons. So that would be 1s2, 2s2, 2p6, 3s2, and then I count 2, 4, 10, 12. I have 3 more to place. After 3s comes 3p. I don't need to put the whole 6 in there though. 2, 4, 10, 12. I only need 3 more. Okay, so in this time, if I use the same rules I did for chromium, the highest principal quantum number, that's the 3rd one, and there's 2 here and 3 there, so there's 5 valence electrons, just like the trick showed me, and so therefore it would be exactly the same picture.